Making predictions using probability. You can do this one of two ways. You can print out the worksheet if you want. It's also loaded on Schoology. Do it and then check your work. Or you can just do the problems on notebook paper, kind of like we did in class. Do them along with me. Or if you want to try them on your own first by pausing the video and then let it play and check your work, you can do that too. Let's get started. We're going to look at number 1. Number 1 says Sarah's responsible for ordering drinks for the company picnic. She asked 50 people to name their favorite drink. The table shows the results of the survey. Sarah is ordering 40 cases of drinks. How many cases should be water? Well, we know that this is a prediction problem. It doesn't say prediction anywhere, but my clue to it being a prediction problem, trying to predict what will happen in the future, is this word right here, should. My lightsaber will light the way. So I know this is a prediction problem, and predictions always start with looking at what really happened in the past. And that's where we're going to use this data over here from the chart. We're going to start by writing our word ratio. Remember, a ratio is just a fraction. And to put it in words, what we're looking for specifically is water. That's our favorable outcome. So I'm going to write water. Yes, this is what you would be writing on your paper. And out of the total, or total drinks. So I'm going to start with the facts. The facts are that, let's go to our chart here. There's my lightsaber. Here's water. I know 15 people chose water. So I am going to come back over here and write my fraction, 15, out of, now I've got to add, and I'm adding 20 plus 10 is 30, and plus 5 is 35, and plus 15 is 45, and then 50. So 15 out of 50 people chose water. 15 water, 50 was the total drinks. I am making a prediction. This right here is what really happened. But I'm asking to make a prediction about how many we need to order of water if she orders 40 cases. This is a prediction. I'm trying not to order too much or too little. I know in the past 15 out of 50 drank it. So I want to know, well, if I have 40 total drinks or cases, what would I order in the number of water? I'm going to set them up side by side because I want to use this data to help me answer this question. I want to find the relationship between these two here. So I look at those, I don't see one. There's nothing that I can divide 50 by and get 40. So that doesn't mean I can't work this. That just means there's another step there. Remember, guys, what do? You're stuck. You don't know what to do. I've got 15 50ths. I don't have a relationship. I can reduce or simplify. What can I divide that by? If you thought of 5, you're right. So let's go ahead and reduce 15 50ths, and we get 15 divided by 5 is 3. 50 divided by 5 is 10. If I have 3/10, remember these are equivalent, so I can now, instead of using 15 50ths, I'm going to use 3/10 and see, is there a relationship there? There is. It's times 4. So that's times 4. Woo, my paper's getting messy. That's times 4. 3 times 4 is 12. So if I order 40 drinks, 12 need to be water. Right there. I need to see all this work on your paper. Remember, we can always go back. Here, our word ratio reminds us where all the data is supposed to go in our fraction. A lot of work to make a prediction of what we should do in the future. All right, let's go to the next one. Number 2. The Forest Service is tracking the number of male deer in the 20 acres of forest. They tagged 40 deer, and of those 40, 15 were male. Based upon this sample, how many male deer are in the forest if the total number of deer is 480? All right, well, let's look. This is another prediction question. I don't see the word prediction, and I don't really see a future word, but I do see based upon this sample, upon this data, how many are in the forest if? We still don't know for sure. We're going to make a prediction. If there's 480, how many would there be? Well, we have to start again with what we know. Let's make our word ratio to remind us what it is we're looking for out of the total of what? Well, we're looking for male deer. Those are also called bucks. Out of all the deer. So let's see what we know for sure. What really happened that we have the facts for? We know that they tagged 40 deer and 15 were male. So how many were male? 15 out of 40. Okay. All right. So we know for a fact out of 40 deer, 15 of them are male deer or they're bucks. But we have a feeling there's more than 40 deer in this forest. We're thinking maybe there's 480. So if that's true, we need to make a prediction. If there's 480 total deer, that would be all deer, how many would be bucks? We've got to use what we know for sure, which is right here. Try to find a relationship. Is there anything times 40 that can make 480? There is. There is a relationship. And actually, it's 40 times 12 makes 480. And if you just take those two zeros off, you see a 4 and a 48. 48 divided by 4 is 12, and then we just add a 0 on. So I know I've got a relationship. So I know I can use that here. I'm going to take 15 times 12 to help me find my answer. Now obviously it's going to be a bigger number, isn't it? All my answers are bigger numbers, and I'm multiplying 2 digit by 2 digit. I'll give you a second, pause the video, see if you can find your answer. All right. Hopefully you've done your math and showed your work and found 15 times 12 is 180. So based on this, if there were 480 deer in the forest, that would make obviously more male deer, wouldn't it? And it would be 180. All right. Make sure you've shown all your work. Let's keep going. Number 3. In number 3, we have a survey. 3 out of 5 students said that they participate in a sport. At this rate, how many students out of 100 would be expected to participate in a sport? So this is definitely a prediction question again. Remember, prediction uses probability to tell what might happen in the future. And here's my clue that this is in the future, would be expected. It hasn't happened yet. We're trying to figure out what might happen. We have to use what we know. We're going to set up our ratios. A ratio is a fraction. We're going to set up our fractions. Remember, this is probability of what might probably will happen, okay? We're making this is an experiment, and we are making a prediction. All right. We know 3 out of 5 There's my fraction right there. It's spelled out for me, but it's there. Be careful. Participate in a sport. At this rate, how many students out of 100 would be expected to participate in a sport? Okay. So we're going to have students who participate out of all students. That's what we're looking at. Okay, so if I'm looking now at my clues, at what I know, the facts, when I really did this survey, how many did we find participated? That would be 3 out of 5 total students. So 3 out of 5 said they would. But obviously there's more than 5 students in a grade level, right? Or whatever it is we are trying to figure out. So we're estimating there's about 100 students. We're trying to figure out how many out of 100. So I'm going to make my fraction bar out of 100, write it just like it reads. And now I've got my fractions set up next to each other so I can find the relationship between them to see if I can figure out if 3 out of 5 participate, how many out of 100 would. And looking at these two, I can tell there is a relationship between 5 and 100. I can multiply 5 by something to get 100. Go ahead and show your relationship on your paper. I hope you remembered that 5 times 20 is 100. So to find my missing number, I simply do the same relationship that I have at the bottom, and 3 times 20. Well, I know 3 times 2 is 6, and add a 0 has to be 60. And there's my answer right there. 60 out of 100 would participate in sports, probably, most likely, based on the facts that I've already found. All right, last one. Here we go. Okay, number 4. Keisha rolled a 6-sided number cube with sides numbered from 1 to 6. What is the probability that she got a number greater than 2? All right, well, obviously she's rolling just a regular dice, numbered 1 through 6. And we're wanting to find out, she has already rolled it, but we're wanting to find out what was her chance, her probability to get a number greater than 2. Again, we can write that word ratio, but this isn't necessarily a prediction because she's already rolled it. We're just trying to figure out her chances. So let's look here. We're looking for a number that is greater than 2 out of all chances, right? Okay. Well, how many chances on a 6-sided number cube, 1 through 6, how many numbers are greater than 2? Well, obviously not 1. 2 would not count. It has to be bigger. So we have 3, 4, 5, and 6. So how many chances does she have of getting, if she rolls that dice one time, how many chances does she have? She's got 4 chances out of 6 to get a number greater than 2. Looking at our answer choices, it's not there, is it? Well, I bet you know why. Because we have to do what? Oh, I heard you. Reduce. That's right. We can divide this by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. And you get 2/3. All right, I hope this helped you understand this a little bit more and to know when you're making a prediction and when it's just probability. All right, we'll bring this to class tomorrow. Have a good night. I'll see you then.